Planetterrian Daily, episode 76. Today is June 2nd, 2026. Here's your science and health briefing. Smartphone cameras can now measure resting heart rate passively across skin tones using facial video alone. Researchers demonstrated that short clips captured during ordinary phone use can extract both heart rate and resting heart rate without any attached sensor. The system performed consistently across pigmentation levels, marking the first real-world validation of passive smartphone monitoring. The approach relies on subtle color changes in skin detected by the front camera and processed through AI models. Next steps include scaling the method to track daily variability in larger populations. Now, shifting to a very different area of research. A new commentary examines how passive monitoring technologies might affect physicians' ability to perform core assessments without automated assistance. Authors draw parallels to aviation, where automation increased rather than reduced the need for human oversight. The piece argues for deliberate training protocols that preserve diagnostic vigilance while integrating new tools. No specific trial data are presented. The focus remains on implementation safeguards. On a different note, data from nearly 4,000 participants showed reductions in both impulsive and planned aggressive behavior, regardless of dose, duration, age, or sex. DHA enrichment in prefrontal cortex membranes is proposed as one mechanism supporting improved impulse control and emotion regulation. Authors state there is now sufficient evidence to consider supplementation in community, clinical, and justice settings. The effect appeared at both low and high intakes. The meta-analysis covered 29 trials. Next up, the device continuously samples cerebrospinal fluid and analyzes biomarkers in real time for patients with brain injuries. Earlier detection allows interventions before standard culture results return. The system was tested in clinical settings where timing directly affects outcomes. Further validation across additional injury types is planned. Building on that mechanistic view, we take a short deep dive into how memory retrieval actually operates. Researchers mapped fine-scale anatomy in the RSC and linked specific cellular arrangements to successful recall and spatial orientation. The work used rodent models to trace how these circuits integrate past experience with current position. Disruption of the identified structures impaired both memory access and wayfinding. Follow-up studies will test whether similar organization exists in humans. The Queensland Brain Institute work isolates specific cellular structures in the retrosplenial cortex that enable memory retrieval during navigation. By linking these microstructures to behavioral performance in rodents, the study clarifies how distributed circuits convert stored information into action. Most people picture memory as a mental video library that simply replays stored scenes on demand. In reality, retrieval is an active reconstruction that pulls elements from multiple brain regions and reassembles them each time. Right now, as you recall what you had for breakfast, your retrosplenial cortex is helping bind spatial context, timestamps, and sensory details into a coherent episode, rather than pulling a fixed file. Signals supporting this binding travel through circuits that can be mapped at the level of individual cell clusters, not diffuse networks. Activities strengthening spatial navigation, such as varying your daily walking routes, may support the same circuits used for everyday recall. Watch for upcoming human studies that test whether targeted navigation training improves memory performance in older adults. Now, shifting focus. The attenuated systems allow simultaneous regulation of multiple RNA targets without crosstalk. Researchers demonstrated programmable on-off switching across several genes in a single cell. The approach expands the toolkit for engineering microbial communities with precise expression patterns. Further work will adapt the switches to additional bacterial species. The new Cas13d variants were reported in Nature Biotechnology. From engineered microbes, we look at engineered habitats that aim to offset biodiversity loss. Created meadows in the Netherlands compensated for habitat loss to development and sustained bee and hoverfly populations. The study provides the first direct test of biodiversity offsetting effectiveness for these insects. Species richness and abundance were comparable to reference sites when floral resources were adequate. Monitoring will continue to assess long-term stability. The findings appeared in the Journal of Applied Ecology. Before we go, keep an eye on follow-up work testing whether similar RSC organization exists in humans. That's Planetterrian Daily for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for listening, and I'll see you tomorrow. And before you go, this show is part of the Narrow Network, a family of daily podcasts covering tech, science, markets, and more. If you enjoyed today's episode, give Models and Agents a listen, your daily briefing on AI models and agents. You can explore the whole lineup at neuronetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.